Okay, in this version of guide sheet number 2, we're going to be looking at using some of the mathematical relationships that can speed things up for us when we're trying to add vectors. One of those is Pythagorean Theorem. Whenever we have a right triangle of 3 sides, which are called A, B, and C, C being the hypotenuse of the triangle, the relationship, as long as one angle is 90 degrees, is that a squared plus b squared equals c squared. Now, if a and b are our vectors and we place them head to tail, and we want to add them together to get the resultant c, then if I take a squared plus b squared, take the square root of that, I will get c. So being able to do this is one of those things that mathematically can speed up your life as we add vectors in 2 dimensions. So in the one down below, we want to find the resultant, and in both cases, Dexter's walking a distance in one direction and then 20 meters in another direction, which is at a right angle perpendicular to that. So 225, 9 degrees from that, 315. Again, the resultant vector is always the straight line vector from where you started to where you finish. So that is the resultant for that one. For this one, here's where I started, and here's where I finished my walk. At least Dexter did. So that's the motion that we're talking about. Those are the 2 resultants. Now, they are the hypotenuse of right triangles. So we can take advantage of that. Again, this is 20 meters and 60 meters. If I want to know this resultant, I can use a squared plus b squared equals c squared. This would be a, this would be b, this is going to be c, my resultant over here. 20 squared plus 60 squared. Now that's going to be meters squared. That's equal to c squared. Then to take the to get the actual resultant's length, I want to take the square root of those 2. Okay, so 20 squared, 400, plus 60 squared, and then that gives you 4,000. Then you want to take the square root of 4,000, and you get 63.2. We only have 2 significant figures, so I'm going to have to round that off to C equals 63 meters, and that is the resultant displacement. Now, in that case, again, we are just determining the magnitude. We would also need to know the angle if we're going to report it as a vector. We'd want to measure the angle from here. There are different ways to do that, and we'll look at that later. Right now, we're just looking at the magnitude. Over here, it's going to be the square root of 50 squared plus 20 squared. If I call this A and B. So a little less distance. Let's see what happens. 50x squared plus 20x squared. And take the square root of that. And you get 53.8. Again, we only have 2 significant figures, so the resultant displacement is going to be equal to 54 meters. Again, that's the magnitude, that's the number part of the vector. We would also have to find the direction if we're trying to determine the actual resultant displacement. So because we're only looking for the magnitude, then all we have to do is figure out the length of that vector. Okay, now if you have multiple vectors that are on north and south components, if we can get to a point where we can add all of the east and west vectors together and get an overall, and then add all of the north and south vectors together and get an overall, we can then use Pythagorean's theorem again to figure out the overall displacement. So that's the idea here. We want to look at the east vectors and the west vectors. Okay. And then we want to look at the south and the north vectors. Now, I just switched up my colors because I didn't switch my pen, but I'm going to use blue for east and west here. 16 to the east, take away 2 from the west, we're at 14 to the east, and then take away 46 to the west, and we're at an overall of 32 meters to the west. Now, if you don't like east and west, think plus and minus. So I got 16 positive plus a negative 2 plus a negative 46. I end up with a negative 32. Negative is to the left, or in this case, we'll call that the west. If I look at the north and south, I have a 2 to the north. So if I go positive north and negative south, I have plus 2. Then 14 to the south, so I'll add a negative 14 to that. And then 12 more to the south, so I'll add another negative 12. And I get negative 24, which means 24 to the south. Now let's get rid of my original drawing for my example, and now what we have is to the south we're down 24, and then to the west we're over 32. So 32 meters and 24 meters. To get our resultant magnitude, again, we would use a squared plus b squared equals c squared, so 24 squared plus 32 squared, and then take the square root, and you get an overall displacement of 40 meters. Again, we can then use some other methods to determine the actual angle of that, but right now we're just getting the overall displacement, the value, magnitude of it. So student B takes a slightly different path and ends up in a slightly different way, but we can do the same thing for them. Again, north-south, let's go plus and minus. Plus 2 takes care of that. Minus 14 takes care of that. Minus 12. Okay, minus 12, and that'll take care of that. And that gives us 24 to the south again. So they move the same distance in the north-south direction. Let's check their east and west direction. So positive, negative, 12 to the negative, 56 more to the negative, and then 36 to the positive. Gives us an overall 32 meters to the west. Now, those are exactly the same two components that make up the overall. Again, 32 over to the left and then 24 down. Now, notice that I drew them opposite this time. I drew 24 down first over here and 32 second. Here I started with 32 to the west and then drew 24 to the south. I can do that because, like any other form of addition, it really doesn't matter what order you add the vectors in. A plus B equals C, and B plus A equals C. Just like with numbers, 2 plus 1 equals 3, and 1 plus 2 equals 3. 32 first plus 24 south second equals 24 first plus 32 second. We get the same value as long as they're in the same direction. Since they are both the same, I don't have to recalculate. This is also going to be overall 40 meters. Okay, so Pythagorean theorem is a very helpful mathematical way to quickly add two vectors. Many times we can get them to be perpendicular to each other and therefore be at right angles. Okay, so there's some of the ways that we add vectors in two dimensions together. Those are skills you're going to have to develop if you're going to be successful with this unit.